Let us begin with an introduction to the operating system, or the OS. The operating system is used for memory management, device management, resource management, and process scheduling. The Embedded Operating System, or EOS, is designed to perform a specific task. The size of an EOS is far lesser than that of a general OS. When Linux was invented, it was initially called the Lunix kernel. Linux was invented by Linus Torvalds, who was using Minix. Lunix and Linux are both operating systems in a sense. Lunix, or Little Unix, is a Unix-like operating system developed mainly for the Commodore 64 and Commodore 128. Linux is also a Unix-like operating system. To be precise, it's the kernel. Click or tap Kernel and Compilers to know more. The kernel is the core part of an operating system. The latest kernel version of Linux can be downloaded from the website kernel.org. The kernel contains the entire source file, which cannot be understood by the hardware as is. Therefore, it has to be compiled. The compiler converts the high-level language of the source file to low-level language so that the hardware it runs on can execute the code. What is an operating system, or an OS? OS is a program or software that governs the functioning of other programs. Let us consider an example to understand this. Microsoft Office Word is a program. If we want to start Microsoft Office Word, we will first have to start a master program that can initiate the Word program. This master program is the OS. One can also think of the OS as an interface between the user and the hardware. Whenever a new hardware is connected to the computer, the functionality, registers, and ports of the hardware should also be known. The user is not likely to know this information. Therefore, the OS makes sure that all this data is available to the user. The OS also hides details of different hardware configurations, such as registers, addresses, free blocks, and the field blocks. For example, if the user wants to use a register or any other information related to the hardware, then they can use this information via APIs. These APIs are provided by the OS. The OS manages access to shared hardware resources. For example, if hardware is shared between two computers or between two processes, the OS provides synchronization between the two processes. It ensures that one process executes at a time. The OS allows the second process to execute and use the resource after the completion of the first process. The OS generally possesses the capabilities of multiprocessing and multitasking. Multiprocessing is the use of multiple processors within a single computer system. Multitasking is having multiple processes running on a single processor. Points to remember. The operating system, or OS, is used for memory management, device management, resource management, and process scheduling. The Embedded Operating System, or EOS, is designed to perform a specific task. The kernel is the core part of an operating system. The compiler converts high-level language of the source file to low-level language so that the hardware it runs on can execute the code. The OS is a program or software that governs the functioning of other programs. The OS acts as an interface between the user and the hardware. The OS hides details of different hardware configurations. The OS manages access to shared hardware resources. The OS possesses the capabilities of multiprocessing and multitasking. What is the kernel? The kernel is a part of the operating system that is always in the main memory. In other words, the kernel is the core or nucleus of an operating system. It interacts with the hardware and is situated closest to the hardware. If we look at the layered architecture of an entire computer system, the user is the top layer, followed by the second layer, which is the OS, the kernel as the third layer, and the final layer at the bottom is the hardware. The kernel is different from BIOS, or Basic Input-Output System, which is hardware dependent. BIOS starts just after booting, that is, after switching on the power button on the system. BIOS is tightly coupled to the hardware, but the same may not be the case with the kernel. The user is provided with two spaces, kernel space and user space, in order to execute any program. In the user space, the user writes the code. If that code requires a specific functionality for privileged access, it will execute in the kernel space. The kernel space is a privileged space where every part of the memory is available, and from here the full-fledged functionality of the kernel can be accessed. Finally, let us discuss how processes can request the services of the kernel through system calls. For example, consider a user trying to open a text file which is on a hard disk. A hard disk is a hardware that can be accessed only by the kernel. As the user does not know the address of the text file, they will give an open command to the kernel. For the kernel, this is a system call. The user is requesting the service of opening a text file, and this is executed by the kernel.
Points to remember. The kernel is a part of the operating system that is always in the main memory. It is the core or nucleus of an operating system. The kernel interacts with the hardware and is different from BIOS or Basic Input-Output System. The user is provided with two spaces, kernel space and user space, in order to execute any program. Processes can request the services of the kernel through system calls.